Hi, welcome to our second video podcast on mechanics, a physics video podcast. This time we're going to look at vectors again, but this time we're going to look at how you combine vectors that aren't acting either parallel to each other or in opposite directions. So let's imagine a simple situation. We've got two displacement vectors. It might be that the first direction vector is that we're going to walk east for 3 miles, and it might be that our other displacement vector is we're going to walk north for 2 miles. So what is the effect of those two vectors combined? Well, when you're talking about displacements, when you're talking about walking, most people can easily visualise that it's a matter of doing one of the vectors. We'll do the 3 miles one to start with, and then adding the other vector onto the end of it. If you walk that way and then that way, the resultant would be, your final displacement would be this vector here. So this vector plus this vector adds up to that vector. If we wanted to know the magnitude of this vector, how long it is, what that distance would be if we'd gone the direct route, there are two ways of doing that. And the first way is to just draw an accurate scale drawing. We could choose a scale of 2 centimetres, say, equals 1 mile. And then we would have 6 centimetres and 4 centimetres. If we drew them at right angles, then constructed a line here, if we measured it off, it would give us the answer. The other way of doing it mathematically, most students prefer to do it mathematically, we could use Pythagoras. We take a squared plus b squared equals c squared, so it would be the square root of 2 squared plus 3 squared would be the length of that vector. If we wanted to give a direction that we'd be travelling, then we'd have to use trigonometry. So we might try and find an angle. We might look at the angle to the 3 mile vector, in which case we would use tan. We would say tan theta, making this angle theta, is equal to 2 divided by 3. So if we did tan to the -1 of 2/3 in our calculator, it would give us that angle. Just going to address another minor issue here. I said we would do the 3 mile walk and then the 2 mile walk. What would have happened if we'd chosen a different order and we tried to do the 2 mile walk followed by the 3 mile walk? Well, the result would be exactly the same, wouldn't it? We would still end up here and have exactly the same magnitude of displacement, and the angle to the 3 mile vector of our displacement would still be exactly the same. Let's just move on now and have a think about some other situations where we might have two forces acting. Let's just imagine we've got some object and we maybe attach some ropes to it or something like that, and we apply a force of 5 newtons in that direction and a force of, say, 8 newtons in that direction. What is the result of that on this object? Well, whenever we're adding two vectors together, we do exactly what we did before when we were looking at the displacement vectors. We simply go along one vector, 5 newtons, and then we go along the other vector, 8 newtons, and the resultant is in that direction. And you can see, looking back to this picture here, that the resultant of those two forces is we're going to be moving the object in that direction. That vector is the same as that vector. Similarly, we could have gone along the 8 newton vector first, or we could have gone along the 5 newton vector there. There are some other tips and tricks to this that we'll look up in the next video podcast, which will be on resolving.